Hello everyone, welcome to this presentation about generating catchment areas for healthcare centers. My name is Fredrik Thorén. I work in a company called Thoréns IT together with my brother Henrik Thorén. We are both FME certified professionals and we are located in the very southern part of Sweden. The agenda for today, I'll explain the assignment I got, focus on demonstrating the analysis, and I'll round up with some conclusions. So the assignment here, I worked for a regional authority, which they administer healthcare in the region. And the thing is that each citizen should be assigned to a healthcare center, and that should be the closest healthcare center by default, so the closest when traveling in a road network. And my task here was to generate catchment areas for those healthcare centers, and they should be delimited by county borders. And as input for this, I had a road network, healthcare centers as points, and counties. So let's have a look at that in the inspector and workbench. So here we have Gothenburg, and I was looking at the region around Gothenburg. And for this demonstration, I looked at the city of Lidköping. They have 3 healthcare centers in the city of Lidköping. I had a county border, and I need a road network to make analysis on. And I don't just want the road network in the county, I want it a little bit outside, because it should be possible to live in the county, cross the county borders to get to your closest healthcare center. So I'd like to have the road network a little bit outside. And first I can see here that I have one polygon, big polygon of the county, and I also have some part of the county placed down here. So I replaced this with a hull replacer. So I get that little polygon contained in the big polygon. And after that, I made a buffer to make it look like this. And within that area, I chose a road network. And this road network here, I created a counter for, so each link has a unique counter, this one called 6107. And since I have 3 healthcare centers, I want 3 copies of the road network as well. So I cloned the road network in the same amount of copies as I have healthcare centers. So I had 3 healthcare centers in the county. I have this road network link 6107, and I have 3 copies of it. That's network analysis number 0, 1, and 2. And a really important thing here is that these healthcare centers, these 3 points, they also have exactly the same attribute called network analysis number 0, 1, and 2. So we can see here on the cloned road network analysis number 0, 1, and 2, and for the healthcare centers also 0, 1, and 2. That's the input for the analysis. We have healthcare centers, road network, and the county border. And for this analysis, I'm using NetworkCostCalculator. And so the actual analysis that we're gonna demonstrate starts here with the NetworkCostCalculator. And the NetworkCostCalculator, it computes the shortest path from a source object. Source object is the healthcare centers to each connected object. That's each vertex in the road network. And then it assigns the cost, that's the distance. It assigns that as a set value on each coordinate, so on each vertex. Let's see what it looks like. So in the network cost calculator, as I said, a really important attribute, network analysis number, which is the same for healthcare centers and road network lines. By grouping on network analysis number, I get 3 groups of analysis. And I'll weight it by length, so distance, and I output the distance as set values. And I go ahead and filter it within my county. Or we can have a look at the 4.1 network analysis first. We have that here. So let's look at the same link. Sorry. We have the same link here. We have 3 copies of the link, 1 for each network analysis. We can see here that we get on the set coordinates, we get the distance. So this is when looking at network analysis number 0. That's the one over here. Then we have these corresponding distances. And if we look at network analysis number 2, which is the closer one, we get some shorter distances here. So what I like to do is, instead of looking at the link as a whole, I'd like to look at each vertex, so each coordinate, and I go ahead and divide the links into points by shopping it by vertices, and maximum vertices of 1 that will create points. And I will also like to create a counter that is unique for the road network link and the network analysis number. And I also know that the set coordinate here is the distance to the healthcare center. So let's look at that. The vertices 4.3. So now they are points. And here we can see on the same road network on vertex number 1, that's this coordinate here, vertex here, we can see we have network analysis number 0, 1, and 2 and corresponding distances. So what I like to do is to aggregate these 3 points, which are placed on the same location, aggregate those by ID road network link and vertex number, and put these values here in a list so I can sort out the shortest distance. So I go ahead and make an aggregator. I group by ID road network link and vertex number. I create a list called distance analysis number list. And I add these 2 attributes, the distances and the network analysis number. We'll have a look at that in the inspector, 4.4. Take the same coordinates, so 6107, vertex number 1. Now we have the list here with distances and corresponding network analysis. So for 0, 1, and 2, we have corresponding distances. And now I'd like to sort this list by the shortest distance. So I use a list sorter for that. I sort by distance to healthcare center, numeric ascending, so the shortest distance first. And when I've done that, I can grab the corresponding network analysis number in the first item with the shortest distance, and I call that closest healthcare center. So looking at 4.5, we can see here we have an attribute called closest healthcare center. That's the healthcare center number 2. So 0 and 1 are further away. So now we have a result. So in each of these points, we know which healthcare center is the closest. And I'd like to go ahead and make surfaces around those points. So that's the next part in the analysis here. And I'll do that with the VoronoiDiagrammer. And the VoronoiDiagrammer works like this. We have some input points, and it creates polygons around the points like this. And when doing that, let's see, change to Voronoi. So here we have polygons. You can see all of this polygon, the closest healthcare center there is number 2. And here we also have number 2 and 2. Going closer to healthcare center number 1, we can see it changes to 1. Here we have closest to healthcare center number 0. And of course, we like to now remove all the interior boundaries which share the same value of closest healthcare center. And we'll do that with a dissolver, and then clip it by county to get our catchment areas. And then the result looks like this. We have catchment areas, one for each healthcare center in the county. And we also got the small little polygon included here. So that's the analysis to generate those catchment areas. And I've made a summary of the analysis here. This is not the correct FME script, as you can see here. So what I did was I took my healthcare centers, create a counter, network analysis number, and I also counted how many healthcare centers there are in the county. I took my road network and county and clipped the road network by county and made it a topologically correct road network. I took the number of healthcare centers and added to the road network, and I made as many clones as I had number of healthcare centers. And I created a county of the clones, of the copies, that's named exactly the same as the counter on the healthcare centers. And then on the network cost calculator, I could group by this attribute network analysis number to calculate the shortest path and store the distances as set coordinates. And then I get this result. This is for healthcare center number 2. And then afterwards, I could sort the coordinate values to find the shortest distance, and then find the corresponding healthcare center with the shortest distance. And then I used the VoronoiDiagrammer to create a polygon around each point. And then I dissolved the interior boundaries for areas with the same value. So that's just a summary of the analysis I made. Conclusion here, I ran this on a really detailed road network where I analyzed each vertex, which gave us really high accuracy. It all processes in about 4 hours. It's a process that will only run like every 3rd month or so. And that should be when healthcare centers have changed, like they have opened a new one, closed some, or moved to another location. Or if the road network has changed, or potentially also if the county borders changes, but that doesn't happen very often. Most important thing here is that it's a solution that the customer is really happy with. That's the most important thing for me. Finally, I'd like to say thank you for listening, and thanks to Safe Software for letting me present at FME World Fair. And please contact me if you have any questions. Thank you.